Okay, good afternoon, ladies and gentlemen, and thank you very much for having me here at the moment. The talk of my, or the title of my talk, as you can see, has nothing to do with insecticides, insecticide resistant, or basically we're introducing here another concept which may be used to control mosquitoes as well. So the outline of my talk is basically that I'm focusing on stegomyia mosquitoes, on Aedes aegypti and Aedes albopictus. And I will give you an update on the current trap technology for these species. Those are basically two trap types that have been developed in recent years, and one is for host-seeking mosquitoes, and the other one is for gravid mosquitoes, lethal ovitraps. And then I want to summarize recent studies that have been published on these traps, on the use of these traps, which were used as control tools in mass trapping against Aedes aegypti and also Aedes albopictus. And then in the end, I will introduce the 2+1 concept. So this is like the first trap that I want to show, shortly introduce. Most of them probably know it by now. It's the BG Sentinel. This is the newest version of the trap, which has been developed by us a long time ago by now. It was first on the market in 2006. It's especially good against stegomyia mosquitoes. Does not need carbon dioxide. It's very good for Aedes aegypti, Aedes albopictus. It's a collapsible trap, and it is using a lure which is which contains substances that are also found on human skin. And this one is a trap which is used generally for the monitoring of mosquitoes, of Aedes mosquitoes. And in the years, it has basically become a little bit more obvious that this trap actually catches so well that the idea was there, maybe we can also use it as a control tool. So the first study that was done was performed here in Brazil, in Manaus. And it basically, the concept was to have different clusters of houses. We had, all in all, we had 12 clusters. 6 were in the intervention areas where we distributed BG Sentinels. Each household got a BG Sentinel. There was a coverage of 60%, and we had 6 reference areas. And every 2 weeks, all these clusters were monitored with BG Sentinels, 4 BG Sentinels each of these areas. And the results were a little bit mixed, but still quite promising. So what you see here on the left side is the baseline study, where we studied both of the later intervention area and the control area, or the reference area. And then in the rainy season 1, we basically introduced the BG Sentinel traps, and then came a dry season, and then came another rainy season. And if you look at these numbers, basically you can see that especially in the rainy season 1, the intervention area had a significant lower amount of mosquitoes that were trapped in the monitoring traps compared to the control area. During the dry season, the whole thing went down, and in the second rainy season, there was also a very low amount of mosquitoes in general. If you look at this in the graphs, then the most important thing is this is the first season where we basically see that the dotted line is the reference area, and the straight line is the area where the traps were mounted. So we can see that here it's relatively promising, especially in the first rainy season, that there was a marked and significant lower numbers of mosquitoes being captured in the areas with traps. There was another study that we did with albopictus in Italy. And that was a little bit similar, but we had 2 intervention areas and 2 reference areas. The intervention areas were basically 2 private houses, well, 1 private house, and the pair was another private house as well, 1 apartment house, and actually 2 cemeteries. And in these cemeteries, there's lots of albopictus. And we measured the human landing rate, and these are the curve which presented itself. You have again here on top, you have the human landing rates in the areas which were not treated with traps, and here on the bottom line you see that the human landing rates were basically going down significantly, almost to zero. So those were the traps for the host-seeking mosquitoes. And these are the latest developments in deadly ovi-traps, how I would call them. These are, first of all, on the left side, this is developed by the CDC, by McKay, Amador, and Barrera. They call it the autocidal gravid ovi-trap. It was first published in 2013. And on the right, there is the GAT trap, the gravid Aedes trap, developed by Iras, Buhagiar, and Ritchie. Iras is here in Belo Horizonte in Brazil, and Scott Ritchie and Tamara Buhagiar are in Australia. So maybe I first introduce a little bit the AYGO trap, which is basically a big bucket, like I think it's an 80-liter black bucket with several other things that are put on top of it, a lid and a chamber up here, and in the chamber you have a sticky board. And so this sticky board actually catches the mosquitoes that are trying to enter the whole bucket to lay their eggs. That's the sticky board. And there was some very interesting studies being published by Barrera et al. This was the first study where they used the AYGO traps. They introduced, basically, they put 3 to 4 AYGO traps per household in an intervention area, and they had another reference area. The coverage was 81%, and you can see here, this is a little bit complicated, but you can see the straight line basically is the reference area, and the dotted line is the line for the intervention area, and on top is basically they also used AYGO traps as sentinel traps, and this on the bottom there is the Beachy sentinel trap, also used as a sentinel trap. And in both cases you see that in the intervention area the trapping of mosquitoes went down significantly. And that's a continuation of this study. In this case, they only used the AYGO traps as monitoring tools, and now they had four areas, 2 intervention areas. Here was a coverage of 85% of the households had 3 AYGO traps, and here you can see the same thing, that basically the dotted lines are the areas where there was no intervention, and down there was the straight line down here is the intervention areas. Again, a marked difference in catch rates. This is the last paper which was published recently, which actually also showed that because those were areas where there was a chikungunya epidemic also, that basically the infection rate for chikungunya were lower in the intervention communities compared to the non-intervention communities. So that's a really interesting part as well. So now I want to introduce the other trap, not the AYGO trap, but the GAT trap, which basically, you can see it also on the outside. It's a little bit simpler than the AYGO trap. It's also a little bit smaller. It consists only of a bucket here, filled with water. There is a chamber, a translucent chamber here, and a black entrance funnel where the mosquitoes can enter and try to reach the water. And then if you, for example, place an insecticide-treated net here, the mosquitoes get entangled in that net and die. Another thing which you can also do is, that's the insecticide-treated net, you can also do is you can basically rub on the inside of this translucent chamber, and then the mosquitoes, when they see that they cannot find the water, they try to fly out again, and then they don't take the wind the way they got into that, because that's black, so they try to fly to the light, and then they hit the translucent chamber and get stuck to that chamber, and the baby all and die. And Scott Ritchie from Australia actually did a comparison study between the Singapore sticky ovi trap, which we've seen before. This here is again the AYGO trap in the middle, and the gut trap on the right. He did this study in 2014 and 15. It's not yet published, but he basically compared the efficacy in catching of these 3 traps. Too bad for Singapore, the Singapore trap basically was the worst, or was not as good as the 2 other traps. So Scott only compared in the next study only compared the AYGO trap and the GA3 trap. And this is he had one outlier where the GAT trap captured 26 females in one day, so he kicked that out. But basically, you can see here that that according to this study, and this is so far the only study, it was a Latin square design with all in all 30 replications, that the GHG trap had better catching rates than the AYGO trap. So if we take all these things together, then we basically think, taking all this together, we see that the trap development has greatly improved the efficacy of traps for dengue, Zika, chikungunya vectors of the subspecies, subgenus Stegomyia. And there are strong indications that traps both for host-seeking mosquitoes and traps for gravid mosquitoes can significantly reduce Aedes population sizes. And we have heard yesterday that this may well have a big impact on the transmission of diseases. And combining both these methods, according to our thoughts, should widen the scope of targeted mosquito stages. In this case, it's of course physiological stages of mosquitoes, thus raising the probability of success. The problem so far was, of course, especially the active trap, the BG Sentinel is, as we have heard also, is not the cheapest, and it's also basically made to be put up and moved. So it's not a trap that is really made to stand there for a very long time. So basically, what we did, we told our engineer to make a trap cheaper and maybe even more beautiful. I don't know. Judge for yourself. This is the Beachy Bowl. We didn't come up with a better name than that. Everybody we asked, so how would you call this name? They all thought about a salad bowl. So now it's called the Beachy Bowl. It's but I think it's actually not too bad looking. It's made all of plastic, so there is no fabric or anything like that in there. The fan is now a little bit weaker, less loud. Because of the form of the trap, actually the airstreams are still the same. The important thing is that it does not have a catch bag. So basically, like in the BG Sentinel trap, if you use it for a very long time, then the catch bag gets stuffed with mosquitoes and other stuff. So the suction power goes down. Here, basically, the whole trap is the catch container. So, and we put 10,000 mosquitoes in the trap, and you could hardly see them. So this trap can actually run for a very long time. It's made for mass trapping. It can run for a very long time, and it needs electricity. We still didn't come up with a really good trap for host-seeking mosquitoes without electricity. Sorry for that. We're working on it, but it's very difficult. So, finally, I wanted to introduce to you, and maybe if there's anybody interested here to do some joint research on that, the 2+1 concept. Basically, what we want to do is, according to the studies that have been done before, we want first to initially do a source reduction of in the area that we want to treat, with everything in the book. And then we want to distribute per household 2 traps targeting the gravid mosquitoes, the GAT trap, and 1 trap targeting the host-seeking mosquitoes, the Beachy Bowl. The whole thing is, of course, targeting 2 different stages, physiological stages, thus rising the success rate, as we think. Concerning the price, if we calculate it really well, and if we have a larger project, then we can actually sell one of these sets for around $50 per set. They need bi-monthly servicing, and the product life is designed to be a minimum of 3 years. And if anybody is interested, please join me and we can talk about when and how and where to test something like that. And almost 15 minutes. Thank you very much.